This video will show how to graph the functions f of x equal x cubed minus x and also f of x equal the square root of 2 minus x. In this first graphing example, we're going to graph f of x equal x cubed minus x. Now remember that f of x is the function notation that we replace y with, and we can also replace f of x with y, so we can think of this as y equal x cubed minus x. So we're just graphing an equation here. Now the general method of graphing involves finding the intercepts. The y-intercept is easy to find. You just let x equal 0. If you plug in 0, you get 0 cubed minus 0 for y. So the y-intercept is 0, 0. To find the x-intercepts, you have to let the equation equal 0, because y equals the equation. And when we let y equal 0, we get 0 equal x cubed minus x. We solve this equation. It's a higher degree polynomial that's factorable, so we can solve it. We factor out the x using the distributive property, and we get the equation 0 equal x times x squared minus 1. We can factor that difference of squares into 0 equal x times x plus 1 times x minus 1. And then apply the zero product law to each of these factors, and we get x equals 0, x plus 1 equals 0, and x minus 1 equals 0. Solving these latter two equations, we get x equal 1 and x equal negative 1. And then we also have x equals 0. So the three x-intercepts are negative 1, 0, 1, 0, and 0, 0. 0, 0 happens to be both an x-intercept and a y-intercept. Now we're going to graph these. We plot the points negative 1, 0, 0, 0, and 1, 0. And now we need to find points on each side of these x-intercepts. Some good values to plug in for x would be negative 2, negative a half, 1/2, and 2. This would give us points on each side of these x-intercepts that we just found. So we're going to plug in those values into our function y equal x cubed minus x, calculate the y values, and then plot those points and finish our graph. We plug x equal negative 2 into our equation. Negative 2 cubed is negative 8. Minus a negative 2 makes negative 8 plus 2. And that results in y equal negative 6. We plug in negative 1/2 for x. Negative 1/2 cubed is negative 1/8. And then we subtract a negative 1/2, which is adding a half. So negative 1/8 plus a half, which we can think of as 4/8, results in positive 3/8. When we plug in x equal positive a half, we get 1/8 minus 1/2, which is 1/8 minus 4/8. That makes negative 3/8. And when x equals 2, we get 2 cubed 8 minus 2, which is 6. So we have our points, our additional points, and now we plot them. We plot the point negative 2, negative 6. We plot the point negative 1/2, positive 3/8. We plot the point positive 1/2, negative 3/8, and we plot the point 2, 6. And if you notice, these points line up kind of in a nice smooth curve. The next thing we do is just draw a smooth curve through all these points to get our graph. And now I'm going to carefully, or as carefully as I can with this computer mouse, draw a line through those points from left to right. And you can see the smooth curve goes up, dips down, and then goes up again. And that's not the best. Here's a better representation. Actually, this is quite a bit better. And if you notice something, there's a symmetry present here. The symmetry with respect to the origin. That's because this is an odd function. If we put in opposite values of x, we got the opposite y value. So when you see a function is odd in nature, you should expect this kind of symmetry. In this example, we're going to graph f of x equal the square root of 2 minus x. The first step here is to replace f of x with y and rewrite this as y equals the square root of 2 minus x. Now we're going to find the intercepts. The easy intercept to find is when x equals 0. If x equals 0, we get y equal the square root of 2. And the square root of 2 is 1.414. It's an irrational number that repeats forever. We're just going to round that off to 1.414. Now to find the x-intercept, we let y equal 0, and that means the equation itself equals 0, and we solve 0 equal the square root of 2 minus x. It's a radical equation. If you square both sides, you get 0 equal 2 minus x, so x is 2. Actually, you can see that x equal 2 is the only solution you could have here. The x-intercept is x equal 2, y equals 0. So our two intercepts are 0, 1.414, the rounded value of square root of 2, and 2, 0. And we plot both of these, and shown here. Next, we need to find some more points. When we pick our points, we have to keep the domain in mind. For this particular function, the domain is not all real numbers. Remember, the domain is the largest set of x values that results in a real y value. Well, if x is anything bigger than 2, the y value is not real. So for this function, the domain is all real x values less than or equal to x equal 2. So we can pick x equal 1. That's a nice value to plug in because we get a nice easy square root of 1, which is 1. We also pick x equal negative 2. That's also a nice value, but because when we plug in negative 2 for x, we get y equal the square root of 2 minus a negative 2, which is the square root of 4. And that equals 2. So we have the point 1, 1 and negative 2, 2, and then we plot them. And here are our points plotted. Here's 1, 1 and negative 2, 2. Now we just draw a smooth curve through these points. And once again, I'm going to do the best I can just using my mouse to draw the curve through. It ends up being a sideways parabola, or the top half of a sideways parabola. Now here's a little better interpretation of that graph. And once again, you can see it is actually much better than what I was able to plot with my mouse. And you can see how it's half of a parabola turned sideways.